We're back here on Battlesnake Official. We're going to be jumping into another developer tutorial. We've got Brandon Brown is back with us today, which is awesome. We're super excited to have him. He's going to be talking about TypeScript and Heroku. TypeScript's really interesting because we don't have any starter projects that do TypeScript, so this will be sort of a first stab at someone that we know of trying to write a TypeScript snake, which is great. It's not too far removed from some of the existing starter snakes, so it should be interesting. And I know that Brandon was hoping to maybe get a little bit farther than he did with the JavaScript one as well. I'll turn it over to Brandon. Hey, Brandon, how you doing?
I'm doing great. How are you?
I'm all right. It's a pretty good Wednesday.
That's good. Yeah, it's beautiful outside. Sun's shining. Wish I could be out there.
I feel ya. Awesome. So you're gonna do a little bit of a TypeScript developer workshop. Start from scratch and kind of take us as far as you can.
Yeah. I'm basically going to be building off of a lot of the content that I talked about in the previous developer tutorial that I did based on the JavaScript starter snake. So a lot of the code is going to be familiar there. So I suggest if you haven't watched that, go back and watch that. And then, you can continue watching this if you want. I'll do a little bit of a recap of where we've gotten to at this point, but I'm not going to go into a whole lot of the sort of like lower level stuff that is mostly covered in there. I will cover the sort of differences between the two, though.
Awesome. Great. If you're good to go, I'll turn the screen share over to you, and you can take us out. Take us away.
Make sure that we have the right one here. Okay. So I'm currently doing an npm install right now, but what you'll notice is that I'm sitting in my editor right now. I'm using Visual Studio Code, and I have the Heroku website over on the right here. So today I'm going to be covering some of the setup of getting a JavaScript snake set up and then converting it over to TypeScript. Now, I've gone ahead and done a lot of the conversion, so I'll basically just sort of step through some of the conversion steps and go a little bit back and forth between the two. Today, we're going to be basing a lot of the content on the JavaScript starter snake, which is available at Battlesnake Official on GitHub /starter-snake-node. And basically what I've done is I've gone ahead and I've forked this repo and cloned it locally. And then I created a new branch simply named TypeScript and done a lot of the conversion on that myself. If you're interested and you want to follow along, you can view my fork, Brandon B927, the starter snake node repo. And I have a TypeScript branch up. It's visible on the page there. I think that might actually just be for me. But you can go and visit the TypeScript branch, and it has all of the updated code and everything for this. So let's talk about how we got here. So one of the main reasons that you would want to use TypeScript over just plain JavaScript is, one, you have a lot of type safety. And what I mean by that is that you can build out chunks of code and know that the TypeScript compiler will catch any errors for you if you're misusing any pieces of your code that aren't intended to be used in a certain way. So where that comes in handy is when we start building out types for the different pieces of Battlesnake. So we know that if for anyone that's just getting started with this, Battlesnake is effectively a game where you play Snake on a large board. I'm just going to pull up a game here. And basically every snake goes around, but each of these pieces of a snake can be represented as a piece of code fairly easily. And by that, the board is basically just a grid of squares, and each grid can contain an object of some kind, whether it be a piece of food, body of a snake, the head, tail, etc. So we can represent those as pieces of code fairly easily. And by doing that, we have the code over on the left here. So what I've done is I've created different interfaces for these chunks of code. And an interface is basically a description of how the code should be described and how it should be used. In this case, I have a coordinate interface, I have a snake interface, board, scroll a little too far here, a game interface, a game state, and a directions enum. I'll talk a little bit about that coming up here. So each one of these describes a chunk of the code, like I said, a coordinate being an XY value. The board is, like I said, a grid of squares, and it's a matrix of XY coordinates of 0, 0, 0, 1, 0, 2, 1, 0, etc. So from the top left over to the right is 0 across to the width of the board, and from the top left to the bottom is the 0 to the height of the board. And we represent those as different JSON blobs. And I will just bring up the docs and give you a little demonstration again of what the API looks like for Battlesnake. So when you're calling, or rather when Battlesnake, the service, calls your snake, it's going to provide you some data, and you need to provide it some data. When we start a game, we provide, you're provided with the game ID, the turn number, which is going to be 0 at the start, the height and width of the board, where the starting food pieces are, where the other snakes are, and of course where you are in that board. And it's represented as a JSON payload that looks kind of like this. And the interesting thing is we can take this and we can codify this so that we expect specific values and their types in our code. So if we're doing a server, if we get a server request from Battlesnake into our server, we can represent that as a few things. What I've done is I've created a couple very basic interfaces for what a server request from Battlesnake looks like. And that is the game, the top level key here, is equal to a game interface, which if we go back here, right here, has an ID, and that ID should be a string. If it's a number, then some of our code might fail. So we can basically create a system in which we're defining the structure of the code without actually having to write a lot of the logic to ensure that these values, these keys and values, match up to what we expect them to be. So it adds an extra level of assurance that the code is going to work. Someone in the chat asks, does the I in iGame stand for interface? Yes, it does. And the reason for that is it's kind of a convention in TypeScript to put an I in front of an interface object, I'm going to say. And the reason for that is because it makes it kind of explicit that this is an interface. Because what we can do is we can create different objects. So let's export a class game. And if we don't fill this out, this could be used in the form of a game here, but it would be misused and could potentially expose bugs. The other way that we can do this is create an enum, which is basically just a list of key value pairs inside of an object. And again, these can be used in the same way, but again, it doesn't create the sort of safety net that we want and get with interfaces. So we'll swap this back to an interface here and continue on. So again, we have the base server request, and we have the start response, which is the response that we are going to pass back in the start endpoint. So when Battlesnake contacts your snake and says, hey, we're starting a game, here's your information, you need to respond back with some information like the color of your snake, the head type of your snake, and the tail type of your snake. So we ensure that this data doesn't get messed around with, like providing possibly an object or a number or something like that. And again, we do this with the move response. So whenever a move happens in your snake, the game started and every snake has responded, and we are now into the move phase of the game, and we're doing that round robin sort of request game that we play with all of the snakes to get their next move, provided the board state and all the information that you need to make a decision. So these are somewhat very basic interfaces, and you can make them as complicated as you want. But for the sake of this tutorial, these are going to be kept fairly basic. Now, I said that I would talk about the enum here. The reason that we have this as an enum and not an interface is because we don't actually need to type this, but we do need a list of the directions that a snake can go. So again, remember that a snake can only go in 4 directions: up, right, left, or down. And we can codify these so that we can call them in specific instances. And this provides us a sort of level of safety where if we call directions.left, we know that the value of this is going to be the string left, which is what the server or what Battlesnake is requiring. Because if we accidentally leave out the L in a response, then Battlesnake doesn't know how to interpret that and is potentially going to give you a bad move, which could kill your snake and cost you a game. So the reason that we do the enum here is so that we know that when our editor gives us a little bit of help here and allows us to call specific keys on this enum. So that is why we use an enum there. If there's any questions about some of this stuff, feel free to mention it in the chat. I'm going to hop over to the index file here. So one of the things that you'll notice about the difference between JavaScript and TypeScript is, one, we have .ts as the file name. There's a lot of this typing stuff. This kind of stuff isn't really in JavaScript itself. We use some of that typing to, again, provide this sort of safety net that we want. If you clone the starter snake, the JavaScript starter snake, a lot of this code looks very similar, but when you start looking into the TypeScript code, you'll notice that we've typed some of the objects and some of the responses and requests and responses that are used inside of this snake. So what that does is that gives us the ability to ensure that a given response, say the server response, which uses the I server response, type, where is here? Nope, I don't have the I on that. That is why. So let's go and edit these, and then we'll import this. So when you start coding with TypeScript, you'll notice that there's a little bit of intricacies around some of the code and things that can be imported and stuff. A lot of the code uses the ES6 or ES 2015 import syntax. And the reason for that is because TypeScript has this module resolution system, and I'm not going to go into it because it's very boring and very dry. But when you want to import something from, say, another package, you basically import it. And we're going to import the iStart response. And we're going to import it from the types file. Oops. And so we've got this iStart response, and we're going to use it to iStart. Oops. We're using the wrong type here. iServer request is the one that we actually want. There we go. Okay, so we'll notice that that it went from being gray to being an actual type that we're going to use here. So what we can do is we can type this particular data file or data object that comes back from Battlesnake. And now when we want to use data, we know that data has specific values or objects or keys that are available on that interface. So rather than just kind of guessing based on the documentation, we've now codified some of the documentation into the objects that we can use inside of our code. So let's say we wanted to do some work with the board here. We know that the board is going to be of the interface board here. So each board instance effectively is going to have height, width, food, and snakes. And that way our editor can tell us this. So when we call any property that's on the board, we can say food, and we know that food is an array. So it will allow us to select the first index of food in here. But let's say if we were to call food dot some other key name, it's going to error out and say that property doesn't exist on what a coordinate is. And so because a coordinate, following down the rabbit hole here, coordinate is a object with an x and a y. So now we can go back and we can say 0.x or 0.y. And so that way we can get some of those values out of here without having to do a lot of guesswork, because the editor is going to tell us a lot of that. So with that in mind, we're going to start with the start command here, and I'm just going to edit this out. And we're going to move over to Heroku. So I talked about Heroku a little bit in the previous tutorial that I did, but Heroku is a very easy platform to get up and started and running with. Basically, create an account. I've already created an account, so I've passed that step. And then once you create an account, you create an application. So there's this new button up here. I'm just going to zoom this in a little bit. Normally, if you don't have any applications already, you'll see a button right in the center here that's going to create an app that wants you to create an application. So we're going to create an application for this TypeScript snake. So let's call this Brandon TypeScript Snake. That should be available. So we'll create the application here. And much like in the last tutorial, we want to set up the Heroku remote. So Heroku provides a command line utility, which you can install by clicking on the link here. The other option you can do, which I demoed, is that you can connect your repository to GitHub and do automatic deployments and do a bunch of that stuff. We're going to go a little bit more advanced here. We're going to stick straight to the CLI. So I have logged in already, I believe. So let's go Heroku login. And it is going to bring up the command line page to log into Heroku. And because I'm logged in, it provides this nice experience where you just have to log in with a browser and go back to your terminal. So you can see that I've logged in here. So let's clear the command. And now what we need to do is we need to set up our project with this new application. So we're going to copy the Heroku remote command here. Because we've already initialized a GitHub or a Git repository, we can actually take this one. It's the same thing, but just copy it from the right one. So what this is going to do inside of our Git repository is it's going to set up a new remote that we can push to. So normally when you clone a repo from GitHub, it sets the origin as GitHub. And then you can set any other origins that you want. I have one called Upstream, which is the official Battlesnake official repo, so I can pull in upstream changes. But what we just did is we added the Heroku ones. So what this does is this allows us to push to that Git remote, and we're going to do so in a second here. Git push Heroku. Now, normally what you do is you push to Heroku master, but because I'm branched off of the master branch, I need to specify the branch that I need to push, and it's going to push it up to the master branch. So we're going to do that. And what it's going to do is it's going to give you some different output than pushing up to GitHub. This is the build, installing any binaries from Node and stuff like that need to run for this specific snake or for this specific project. So while that's doing that, I'm going to jump over to Heroku again, and we're going to go and view the logs for this application. So I've already done a couple builds on an old app. but we can see here that we created version 3, and gives us the URL that we can go and look at. So if we go and take a look at the logs over on the right here, we can see that the server is listening on a specific port, and that it hasn't crashed. So by default, this snake is running and is able to run, so that's a good thing. So we're going to open this up, and we can see that the default route, which is in the handlers file, is serving up a JSON message, your Battlesnake is alive. So we can say for sure that this snake is up and running. And so now the third step is to take this URL, and let's go and add it to our Battlesnake, and we're going to create a new Battlesnake here. So if you haven't logged into Battlesnake before, just simply go to play.battlesnake.com, authenticate with your GitHub account, and then click on the My Battlesnakes link up on the top right here. So let's call this Node TypeScript Snake. And then we'll take that URL and we'll paste that in here. For right now, I'm not going to make it public, so we'll click Save. And then now what we can do is we can go and create a new game with this new TypeScript snake that we've added. So we'll add it over here, and then we'll click Start. So what I'm going to do is I'm going to bring up the logs so that we can see what is happening. So I've gone back over to the Heroku page and the Heroku logs page, and we can see here that we've gotten some web traffic, and this web traffic is showing that the default endpoint that we looked at, and then we've started a game and we've moved, and because we're responding with random choices, the snake is going to go in random directions. So let's play through this. So snake didn't live for very long, and we can improve that a little bit. So let's go back. Let's take a quick look at this once more, and then we'll go back over to our code, and let's instead of moving in random directions, let's say we want the snake to go in a circle. So what I've done here is the reason. So I talked about an enum being used for directions, and one of the nice things that we can do with an enum is at compile time, it effectively creates an object. And that object has keys and values of left, left, right, right, up, up, down, down. So what we can do is we can actually sort of destruct that and create an array of directions, which equates to what is left, right, up, down, which looks like this. Oops. Left, right, up, down. So this is effectively what we're dealing with here. And if we took this and pasted it in, it would be effectively the same thing right here. So object.values pulls out any of the values of an object, just a handy helper method that we can use here. So these are the possible moves that we have. And what we can do is we can say snake move is equal to possible moves, and we'll pull out just a random one, which is going to be, well, not random, but it's the first one, which is going to be left. And so if we save this file and we do a git status, so we'll do git add git commit -m make snake go left, and then we'll do a git push up to Heroku once more. And we'll see over on the right here that we're going to initiate another build, and then it's going to go out. So while that's doing that, I'm going to explain a little bit about this. So the reason that we can select the 0th index rather than, say, put a string in here is because a direction that is an enum value is implicitly defined as a string, and the possible moves is an array of directions. And so when we pull one out, we can't use the string because the index of this particular value is explicitly defined as a number rather than as a string. So if we tried to access this, the TypeScript compiler is going to complain if we tried to access it with a string. But if we put a number in here, it's going to work. So we'll go back over to Heroku, and we'll just create another game in Battlesnake. And we'll see that the snake should be going left every time. And we just demonstrated that. So we'll go back to our snake, and let's make it a little bit more interactive. Let's make it spin in circles. And what we can do is every tick, we can pick a choice in the list, or we can pick a direction that it can go. And so what we'll do here, instead of using the directions, we'll actually build up a new array of possible snake moves. And we'll go direction, left, and we'll build up a specific order that we want. So we want to go left, we want to go up, right, down, and left. Okay, so those are the order of possible moves that we want. And we want to take the turn of the game and do turn mod. And because we only have 4 of the possible moves, we can put 4 in here. The other thing that we could do is we could go possible moves.length. But if we wanted to, that could change if we wanted to modify this. We haven't defined turn yet. So let's go back. We know that turn is available on server response because if we go and look at it, server request, not response. So if we go and take a look at the server request interface, we have turn, and it's a number here. And the reason that we specify that data is a server request is so that we can specifically pull out the turn from data. So this is going to say that turn is a number, even though we haven't explicitly defined here that it's a number. That's derived from the interface. So let's say we've got the turn. So this is going to be the turn of the game state. And then we're going to do turn modulus possible moves length, which is going to be 4. And let's go and add this. Git add. Let's do that the long way. Git add dot git commit spin in circles. And git push up to Heroku. So we should be able to see, again, this build happening over here. If anyone has any questions in the chat, feel free to post them, and I'll see if I can answer them as I'm going through. Okay, so we're done building here. We should see that this comes up again. There is a question in the chat. Do I recommend using Heroku for this? The nice thing about Heroku is that there's a bunch of different build packs that are used now and that are officially supported, especially since NPM has been around so long, and a bunch of different package managers and all that sort of stuff. They've lended their help to Heroku being able to deploy some of this code that we're using. You could run this locally, and I might jump into some of that in a future tutorial. But Heroku seems to be the easiest way for me to get up and running. Now, that being said, you could, instead of running this directly on Heroku, and I will actually jump into that right now. So the reason that we can run this directly on Heroku is we're using a piece of software called TS Node. And TS Node, for those that aren't aware, is the TypeScript execution and REPL for Node. But what it allows you to do is it is a runtime for TypeScript rather than having the TypeScript compiler output code and then you have to run that output code. This allows us to actually run the TypeScript files directly without having to do a compilation step or a transpilation step. So we use TypeScript node directly in the proc file, which is what Heroku uses to actually run your code. So this is the command that effectively gets run on Heroku. And we can see that if we go back to here, go to resources, let's refresh this page because I think this should have something. Yeah. So our base dyno is running TS node source index.ts, and you can see that our source index.ts is the entry point for our code here in the proc file. Okay, so now that we have the snake running, let's go back and just take a quick look at the logs. It is running on port, so that is good. So let's go and create a rematch. Play. So we can see Snake is spinning around in circles. Not super effective because we can starve. So one thing that we can do is we can do some smarter things with this code. So let's make the snake actually go and look for food. So there's a couple of things that we want to do. I have some code stored that I'm going to paste in. Normally that you would have to write some of this. So let's, I'll paste some of this in here. Okay, so we've taken the turn out of the data, but let's go and grab some more information here. And let's pull this out of data for now. Okay, so we've got some variables here that we might want to use. We've split everything out, so we've got board, which is a board interface game, which uses iGame, turn as a number, and U, which is the a snake instance or snake interface. And we're going to put some more code into here to help us with our moves. So one of the things that we want to do is move to a specific coordinate given a up, down, left, or right instance. And what we can do is type this. Directions dot. And we can specify that this is a, we'll leave it like that. So this is going to return a coordinate. And move is head, I believe, is going to be a coordinate. So this is part of the fun of TypeScript, is trying to figure out what types or interfaces you want to use for a lot of your code. One of the niceties of TypeScript is you don't have to buy into a lot of the type system so that you can transition over some of your code easily. There is one setting in here inside of the TS config file, which you can add, which will allow you to do that conversion over fairly easily and allow you to run just plain JavaScript with TypeScript niceties on top. So move is going to be, let's type it as a string for now. Okay, so we have some of these other coordinates. This is going to be iBoard. Oops. Copy that because I might be using it. All right, so basically what we're doing here is I have a bunch of helper methods that allow us to do some calculations around and allows us to basically build out some of the functionality for using it allows us to build out some of the functionality for calculating the methods given some of the moves for a snake. So we have our possible moves here. So let's use that here. And we have just a couple more things that we have to type. Oops, my coordinates. And so we don't need this anymore. And we don't need that anymore. So we're going to calculate what snake move is. And that is the kind of the goal behind this. Because that is the last sort of variable that we need to come up with. So let's do a quick check of the chat here. So for customization, it looks like Sandworm is in the lead at 50%. So let's break that tie so we can figure out what the head. We're going to do Sandworm. So for customization, we'll quickly jump over to the Battlesnake docs. So if you go to docs.battlesnake.com, there is a customizing your snake link over in the sidebar here. There's a list of the snake heads and tail types that you can use. And so the poll has determined we're going to use Sandworm. So let's go and we'll pick Sandworm as the head type. Someone give me a color. Give me a color to use. And it needs to be a hexadecimal number. And while people are deciding what to use, I'm going to quickly go ahead and let's just give this any for now. So basically what I'm doing is I'm going through and I'm typing a lot of these pieces so that we can have some assurance that the code is actually going to work with the expected pieces that we want. I'm cheating a little bit and using any on some of them, just so that we can satisfy a lot of the code here. So as for color, what do we got? We got blanched almond, FFC0CB, I think that's a 0, and sandworm orange. I'm going to go with sandworm orange to follow the sandworm theme. Here we go. All right, what color is this? VS Code, give me a sign. Let's go and look this up. Ooh, that's a nice color. I like that. All right. And let's go and let's customize the tail type while we're at it here. Let's go freckled. I like the freckled bum. All right. So we're coming up on the last chunk here that we need. Okay, so because we are returning a response here, I'll step through this code a little bit. We want to return a default. And so default for now is just going to be right. So we'll go directions.right. Okay, so to explain a little bit of what this code is doing. First section here is we're basically just creating a switch statement to say if we're going up, this is where our head should be, if we're going down, etc. So that is a function called move to chord. Out of bounds is basically just, is this particular coordinate that we're going to specify out of the bounds of the board? A little handy helper for if two coordinates are equal. We have a will collide with body helper. So what this does is when we are looping through the possible list of moves, we check if that coordinate is going to be part of our body. So we don't want to go to that particular coordinate if it's going to be part of our body, because then we'll do a self kill. And then we have our base helper method here, which calculates, given the moves that we've defined, the possible list of moves to the closest food. So because we don't want to starve going around in a circle, we want to make sure that we have some food in our path. So let's actually shorten this up and go object.values directions. Okay, so that's our list of moves. And we can even shorten this up one more. Doing some very, very minor code golfing here. And then we have our last helper method, which is what's called Manhattan distance, or I think it has a more official or more scientific name, but it's effectively gives you the how many sort of moves you have to make to get to a coordinate, the sort of like absolute value of how many coordinates or how many steps you need to take to get to a coordinate, given XY here and XY over here. So we do that to determine whether or not the direction that we need to go is better than the direction in the previous direction. There's a question in the chat: what should I Google to learn more about this sort of stuff like Manhattan distance? So I'm no mathematician, but Pythagorean theorem is a good helper for a lot of doing snake math. There's also pathfinding algorithms, like I think it's called A-star. There's a lot of different A-star implementations for, that is not the one. There's a lot of different implementations for different code languages. That's the word I'm looking for. So I think you can literally go npm install pathfinding or Pathfinder or something, and it will install the JavaScript flavor of the pathfinding algorithm. And it actually, Pathfinder TypeScript, let's say. Yeah, so here's a pathfinding library written in TypeScript. Basically, this will give you a lot of helper methods for being able to calculate coordinate distances and weighting of given two options, like which one is better, all that sort of stuff. So these are the pathfinding and just basically some simple algorithmic math will help you determine, at least when you're getting started, some of the paths you should take for learning. Yes, I agree. npm install is a lot better than trying to learn math. All right, so before we continue here, just double check my code here. Let's do one test to make sure it actually runs. So what we can do to run this locally, we can go npm run start, and it hasn't failed and it's spun up, so I know that I haven't introduced any bugs from that point. And another thing we can do, actually, is I'm going to introduce a new concept to this. So right now we're running the Node Snake, and we'll kill that terminal. So I'm running it. It's listening on port 5000. I'm going to create a new terminal, and I'm going to introduce a application called ngrok. ngrok is a great tool for testing out a snake locally. It's also good for just like web development in general. And the way that is spelled is ngrok. So if you Google ngrok, it will take you to this website. Effectively, what it is it allows you to serve up whatever is on a specific port and make it available online. So rather than having to do like port forwarding and mess with your router settings and stuff like that, it creates a local tunnel to from the ngrok infrastructure to your application running on that particular port. If you create an account, log in, you can download the binary for it. I fortunately have it already. Oops. And if I can type ngrok. The way to invoke it is just simply by calling it. And it takes a bunch of different arguments. The one that we want, because we're not running on HTTPS or anything, is we want to run the basic HTTP on a specific port. So the HTTP tunnel on a specific port. And the way to do that is HTTP 5000. That is the port that we're running on. So we can see here that we have a session with ngrok, and what this gives us is a forwarding address, and it gives you a specific unique URL. So let's copy that, and we're going to create a new snake, and we're going to call this one Node TypeScript Snake, and we're just going to call it local. And this is going to be our local version of our snake. So you take that ngrok URL, plop it in here, click save. So now what we can do is we have our Node TypeScript Snake local and our Node TypeScript Snake, which is on Heroku. So what we'll do is we'll go and create a snake in here, or create a game, and we're going to add the local snake. So this is testing out our local changes. This is not on Heroku, and I want to make that distinction because what we're going to see here is our snake possibly going towards food, and look at that, it's actually going towards food. But this is specifically running locally. So if I bring up this terminal and make it bigger, we can see that we're actually getting requests for the move endpoint, and then we see that we got the end endpoint. So we'll go and we'll create a new game. And we can see here that over on the right, the game has started. So we'll go and play that. And again, this is running directly on our local machine. And we can see that there is a little bit of latency that's introduced by running that on our local machine. So it isn't, I would highly suggest not running this in any competition, but it's great for testing. So now that we know our snake is running, let's stop the ngrok tunnel and switch back over to our Heroku push. So now that we know we have a working snake, we can go back to working with our snake from Heroku. So we'll go and we'll add that, but I'm not going to click start game yet because I need to add it to Git. Let's do a quick Git status. Git add dot -m make snake go for food. All right, so let's do a git push up to Heroku. And now that we're pushed up to Heroku, we'll wait for that to finish. And we should see that, yeah, we've started to build here. We should start seeing some data come in momentarily here. So, yeah, in the chat, someone asked if what's the best thing to Google. I agree that pathfinding and navigation, all that sort of thing, is good to start Googling. Learning JavaScript can sometimes be also a little bit of a barrier, and especially if you've started coding in TypeScript, or you start in TypeScript without actually understanding JavaScript. So my suggestion specifically on that is for the code is to definitely start learning JavaScript first, and then switch over to TypeScript when you feel that you're comfortable working with it, and then start moving some of your code over to TypeScript. Okay, so let's start this game. This should be the Heroku Snake. This is not the local one. We should start seeing the snake going around and getting food. And hopefully it lasts 150 turns, let's say. 150, let's go 200. Oh, almost 200. All right. Okay, so that is the end of that. So let's do a quick recap. We built out a snake in TypeScript. A lot of the code here is typed and gives us the ability to not misuse specific functions and stuff like that. I don't recommend using any. So this is one little cheating thing that I did, is I specified that any is basically any particular, could be an object, could be a string, could be a number, just for the sake of going through this fairly quickly. But when we're working with boards and coordinates, we can type these and use specific interfaces that allow us to get some sort of safety in our code and ensure that we're using objects and stuff accurately and precisely. There is one question in the chat. Is there anything you can only that you can only do in TypeScript versus JS, or is it more about making life easier? Yeah, so I mean, what it really comes down to is your personal preference. I have been using TypeScript for quite a while now, and I know that some of the I know fairly well about most of the functionality in TypeScript and have used it extensively. When you're using JavaScript, you can kind of create scenarios where you push out bugs that are unintentional simply just by introducing complicated code, or by introducing code that doesn't have any type hinting, that sort of stuff. It also, when you're working with a team, it can also be kind of confusing because one person might have an opinion about how code's written and another might have another opinion about how code's written. So it really comes down to what you feel that your project needs. That's really what it comes down to, is what the project needs. Does the project need that type safety? Does the project need a specific consistent way that it's built? All that sort of thing. So it's really up to you about what you actually define as making your life easier. Yeah. Okay, that's been the tutorial, and I'm going to pass it back over to Brad. Thanks for coming and participating in this with me. Everyone have a great day.
Awesome. Brandon, before you go, before you jump off the Zoom here,
yeah.
Tell everyone a bit about what your role is, what you're doing, and where people can find you.
Yeah, probably should have led with that. That's my bad. So I work for a company called Echosec. I've also been a long-time member of the Battlesnake community. I was around after the very, very first Battlesnake event, before it was even called Battlesnake. So I've been participating with the Battlesnake team and everyone that's been involved with it, basically since it was created. And I'm a very diehard Battlesnake fan. I would get Battlesnake tattooed on my back, but I might have to question my life choices if it comes to that.
Yeah, we would all respect it very much, especially if you got it right on your forehead.
Yeah.
Which only one person has come close to doing. Awesome. Thanks so much, Brandon. This has been great. Really excited to get some content up about TypeScript. I also really like that you covered ngrok. I think that's an underutilized tool, especially for Battlesnake stuff. And so I think we're going to try to get some more ngrok tutorial content up. If you can weave it into some sort of future tutorials you're working on, that'd be great. And then we'll also maybe I can jump on stream tomorrow and do some stuff with ngrok too, because I think it's really good. I think it's worth talking about for sure.
Absolutely.
Thanks again, Brandon. And we'll see you next week with some of your other tutorials.
Thanks for having me. And I'm very happy to be doing it.
All right. And we'll sign off there. Thanks, everyone.